Good morning, children. Today we will be discussing about the effect of catalyst on the reaction rate. Then what is a catalyst? A catalyst is a substance which influences the rate of a reaction without undergoing any change. That is, it is not being consumed in a reaction. Influences means it can increase the reaction rate or it can decrease the reaction rate. If a catalyst increases the reaction rate, then it is called your positive catalyst. The example is your thermal decomposition of potassium chlorate in presence of manganese dioxide, MnO2. It gives potassium chloride and oxygen gas. The rate of formation of oxygen gas explains about the reaction rate. So MnO2 increases the thermal decomposition of potassium chlorate to a large extent. Then if a catalyst decreases the reaction rate, then it is called your negative catalyst. And example is, there it is your hydrogen peroxide. Hydrogen peroxide decomposes to give water and oxygen. But if there is your glycerol or phosphoric acid, then the decomposition of hydrogen peroxide is retarded or decreased. So here in this case, glycerol or phosphoric acid is called a negative catalyst. Now that is your, what is the theory for the action of a catalyst? There is the theory is intermediate formation of intermediate product. See this one. A and B. These are the reactants. Plus C. This is your catalyst. So intermediate complex formation. Here will be A, B, C. And intermediate complex will be formed whose life period is very small. So this decomposes to give AB, and C is being, the catalyst is being regenerated. So this is called the intermediate complex formation theory. So A and B are the reactants which combine with the catalyst C to give intermediate product, complex product whose life period is short, and it decomposes to give the product. This is the product and this is the catalyst. Now let us discuss these two positive and negative catalysts in detail. So here is your presence of a positive catalyst. A positive catalyst lowers the activation energy of a reaction. In case of presence of a negative catalyst, or negative catalyst increases the activation energy of the reaction by forming a new intermediate of higher potential energy. Greater the decrease in activation energy caused by a catalyst, higher will be the reaction rate. And here, greater the increase in activation energy caused by a catalyst, lower will be the reaction rate. This can be explained in this way. See the third point. Due to decreased activation energy, some inactive molecules become active. That is, the number of active molecules gets increased, and hence the rate of the reaction increases. Whereas in this case, it is due to increased activation energy, some of the active molecules become inactive, that is the number of active molecules gets decreased and hence the reaction rate decreases. Graphically, let us see in the graph, this is your potential energy of the molecules and this is your collision number, and this is we are going to explain the effect of positive catalyst on the reaction rate. Look at here, the reactants combine to give the products. Reactants combine to give the products, and in this case the activation energy of the reaction is EA. This is the reaction path without catalyst. Reaction path without catalyst. Now, this will be the path this it is reaction path with catalyst, and the activation energy in presence of a catalyst becomes lesser than the previous kinetic activation energy. This portion, the difference in the potential energies of the reactants and the products, this is called reaction energy of the reaction, and this value is the decreased activation energy. Now what happens in case of positive catalyst when the activation energy of the reaction decreases? Then the number of active molecules, that is the sum of the inactive molecules, become active, and since the number of active molecules, we mean that active molecules means whose collisions are effective. So number of some of the inactive molecules will become active. As a result, the number of active molecules will increase, and hence the rate of reaction also increases. Is it clear to you? Now let's go for the presence of a negative catalyst, how it decreases the reaction rate. The same thing is there, but here will be what? This is your potential energy of the reactants, this is the potential energy of the products. So the difference is what? The difference is energy of the reaction, and activation energy of the reaction. This is your reaction path without catalyst. Now, in presence of a negative catalyst which increases the activation energy of the reaction, then we can have this path. Here the activation energy of the reaction gets increased, and this is the reaction path with catalyst, and this one will be increased. The difference is what? The difference is increased activity. In this particular case, in presence of a negative catalyst, the activation energy of the reaction gets increased. As a result, some of the active molecules will become inactive due to increase in activation energy of the reaction. So in this way, the number of active molecules will decrease, which will further decrease the rate of the reaction. I hope graphically it is clear about the positive catalyst and the negative catalyst. Thank you.